So I know there's been a lot of debate about genetically engineered foods,
Yeah.
and that is why even in many European countries they have actually, I guess, banned the growth of genetically engineered food and the consumption of that, and because of that they have started organic farming.
No, no, no. Organic farming is different. Organic farming is a counter move to use of pesticides and chemical fertilizers. Organic farming, in my opinion, is not a countering genetically modified stuff.
So I read a study, and like we had a subject in second semester, and we read about it over there.
Okay, so suppose as a biotechnologist, would you support GMO?
So as a biotechnologist, I think I should support GMO, but
You support GMO. Why?
uh, so it's the growth of science.
Exactly. So the whole thing should be science based. You have said it. It's a growth of science. The entire reasoning should be science based, and there should not be any politics. There should not be any activism or anything. So if the science says that genetically modified food, the scientists who are dispassionate, who are absolutely independent, they say that this GMO is good, we must all adopt it. The same thing happens in food additives. There are scientific experts sitting in WHO and World Health Organization and Food and Agricultural Organization. They have said that these additives at these levels are perfectly safe. That's why they are being used. So we all have to, even in this the present case of vaccination and things like that, it all should be science based. So that's the answer to your question of why do we use additives? Correct?
Yeah.
Yes,
But
Karan.
there is another interesting aspect. Green revolution came into this country and we accepted it without much questioning. Today, we find the number of diabetics have gone up. There are certain regions where the cancer has gone up. Now, should we have got into green revolution or not? Science-wise, yes, your yield went up. Hungry people will come down. But you have also created a whole, like Punjab and all is severely suffering because of that. So what do you have
Correct.
to say about that?
Yeah, I have a good answer for this. I think it's a good answer. Of course, you have to judge the answer. The point is, whenever there is a new technology or a new development or a new science, the focus would be entirely on the advantages of it. The disadvantages don't appear or they do not become apparent immediately. I'll give you a classic example of plastics. We found so many uses of plastics. We never possibly realized that we would be producing so much and dumping it into the sea and killing the whole environment. That aspect was not very clearly known at that time. Over a period of time, we have now realized that, oh my God, we have damaged too much. The advantages don't seem to be so much. We have now forgotten the advantages. We focus only on the disadvantages. The same thing is going to happen to about mobiles. We have no idea what is the long consequences of mobile and microwaves and radio waves. We have no idea. We see only the advantage now. Maybe down the line in 30 years, we may see a different story. That has happened to foods also. That has also happened to agricultural sciences.
In fact, same thing we are seeing with vaccine. No, in a hurry to approve, we are seeing a lot of unusual phenomena. People are vaccinated, still they get the infection,
But
whereas
but
supposed to minimize. Yeah,
correct. But then unfortunately we have no other alternative at this point in time.
yeah. So
So
this is so it's a matter of whether you want to allow the innate immunity to manage it or should we intervene. That's all the basic questions.
correct. So if we had bothered too much about pesticide residues way
Mm,
back in 1960s, possibly
mm.
the green revolution would not have taken place.
Very true. Very true.
Okay. Okay.
Yeah. Chalo,
Okay.
we'll continue. Yeah,
Okay.
you
Let's
can.
continue. Yes.
Yeah, yeah.
Thank you, and we will continue the torture. Like yesterday, we saw an introduction to food technology. We saw certain basic aspects of, we try to define what is preservation, and we also saw what are the causes of spoilage. Now, if you want to avoid the cause of spoilage, we had also identified the causative agents, like we thought of microbes was one of them, and chemical and enzymatic was the second one, important ones. So before, how do you overcome them? So if you want to overcome your enemy, obviously you should have a fair knowledge of your enemy. So that is what the principles of food preservation will focus on. Let's understand our enemy better so that we can develop better strategies to win the battle. Okay. Now let's see what are the factors which are affecting the growth of microorganisms. Now, the type of microorganisms which can grow in food depends upon two kinds of factors. I'm sure all of you know. Intrinsic factors, which are the basic properties of the food. And then you have an extrinsic factors, which is related to the surroundings. Yesterday, one gentleman was talking about relative humidity. Yes, relative humidity is not connected to the product, it is connected to the outside world. So it is one of the extrinsic property. Extrinsic means outside, intrinsic means within. So the growth of microorganisms will depend upon the basic properties of the food and also what is the environmental properties. The intrinsic properties, what are the intrinsic properties? We will see the moisture content and water activity is, one second, sorry. Moisture content and water activity, and then you have got pH and acidity, nutrient content of the food, pH and acidity of the food, moisture content and water activity of the food. Of the food is understood here. And then what is the oxidation reduction potential of the food? And then are there any inhibitory substances present in the food? So that which would help. Okay, these are the intrinsic factors. The extrinsic, the outside world, oxygen, temperature, relative humidity, packaging. Packaging is very important, we saw last time, because it's something which prevents, it avoids recontamination. So packaging is important. Storage conditions, end use of product. We will discuss the end use of product down the line after some time. So these are the basic factors which are which can be woven into the extrinsic factors. Now, water activity. Now, this is something something you must have heard about it. It's a very important concept in food, especially in food preservation. It is one of the most important factors which determines the growth of microorganisms, and it is denoted by the acronym AW. Now, microorganisms require free water for their growth. So this is very important. The microorganisms need water in the available form, or sometimes we can call it as free water. Some water in the food may be in free form, some water may be in the bound form. To give you a simple example, if I mix calcium carbonate and water, this water I have added to calcium carbonate can be called as the free water. Now, Professor Kannan will correct me. I am trying to try my stunt with chemistry. Now, when you have magnesium sulfate and 7H2O, that 7H2O, which is very closely attached to the magnesium sulfate, that can be called as a bound water. And because the calcium carbonate was mixed with water, that water can be very easily evaporated at 100 degrees centigrade. Whereas the magnesium sulfate, the 7H2O, which is bound as water of crystallization, is very firmly bound, and that is very easy to dislodge. You have to go to a much higher temperature. So the food also has got such, all food has got water to a varying degree, but some of the water could be bound and some of the water could be loose or free. That is, the water which is present inside the cells can be considered as a bound water, and the water which is in between the cells, intracellular, right? That can be called as a intercellular, sorry, that can be called as a free water or a bound water. So water activity is a very it's a typical definition: ratio of water of vapor pressure over a sample rho upon the pure water rho zero at the same temperature. This ratio is called as the water activity. Please stop me. This is an important concept. If I am talking, if I am going off the track, please stop me. I will try to explain it again. Suppose if you take a normal water under the particular temperature, the water from the liquid stage will evaporate and go into the vapor stage, and it will exert some vapor pressure. Now, if I add some solutes to the water, what will happen? The solute will bind the water by a hydrogen bonding and not let the water easily leave the surface of the water. Therefore, incidentally, a solution, a water containing some solutes will have a vapor pressure over the product much lower than that of the water. So, rho, that is the vapor pressure over a sample, will always be lower than the vapor pressure over a pure water. Right? I hope I am clear. Please stop me if you don't understand. Now, so this ratio is called as a water activity. Rho upon rho zero at a particular temperature is called as a water activity, and that ranges from zero, which has got absolutely no water, to one, which will be pure water. And all other foods will have a water activity between these two. So, in essence, I want you to, it's very crudely understand, because not many accept with this statement. Crude understanding could be that water activity is a rough measure of available water. I want to caution you here that water content is not same as water activity. Two products may have the same moisture content or water content, but if one product, the water is more bound, then its water activity will be low as compared to a product with the same moisture content but with less amount of water which is bound. So water activity is a measure of bound water, and bound water is important for the microbial growth. And so these are the two important points which you should keep in mind. The third one is that the water activity will range from 0 to 1. So you can measure the water activity of all foods and they will range from 0 to 1. And that will give you lots and lots of idea about preservation, which we will come to it. So, okay, so under a given set of environmental conditions, right, every organism has got its own requirement of free water. That means that every organism, the growth of an organism in a food will depend upon the water activity. So this is the very important point, that the growth of an organism will depend on the available or a free available water. In turn, it will depend upon the water activity. Now, this scale will give you an idea. So, an unfavorable water activity will result in the reduction of the rate of growth. Suppose the water activity is there. Suppose if I say the water activity is very low, what does it mean? If I say water activity is low, what do you understand? Any one of you?
So the
Hello?
available water is less for
Very good. Excellent. Excellent. The available water is less or the bound water is more. So the organism will depends upon available water, and therefore its growth could be affected. Let's see the slide here. You see that you have got water activity ranging from 0 to 1 on the right hand side. If you see uh, uh, above 9, most bacteria require above 9, sorry, uh, zero point 0.9, I'm sorry. So above zero point 0.9, most of the bacteria require above zero point 0.9. So you get a very good simple idea. If my water activity is lower than 0.9, I don't have to bother about bacteria much, because it is the growth of bacteria on food which produces metabolites which could lead to off taste, off flavor, off note, and blah blah blah, and also toxins in case of pathogens like salmonella, staphylococcus, clostridia, and bacillus cereus, and so on and so forth. So now when I come to, suppose if between zero point 0.8 to zero point 0.9 only mostly yeast can grow. If you say between zero point 0.7 to zero point 0.8, it's osmophilic, that is the higher salt loving yeast, sorry, higher sugar loving yeast, and halophilic bacteria is the salt living bacteria, salt loving bacteria. So what will happen is between zero point 0.7 to zero point 0.8, if my water activity is there, I am going to be bothered only by these things. And maybe molds and most of the fungi also require about zero point 0.7 to zero point 0.8. Now, when I come between zero point 0.6 to zero point 0.7, I have osmophilic yeast, and I've got some xerophile molds and things like that. And so as you go down the water activity table, you will find the common ones are not growing. You are growing something. There are some special microorganisms which can tolerate higher salt content, higher sugar content. That's just what it grows. Now look at the beauty. If it is below 0.6, nothing grows. So below zero point 0.6, no microbial activity is permitted, or no microbial activity takes place. So if my product is, the water activity of the product is below zero point 0.6, then I don't have to worry about the microbes. I don't have to worry about the microbes multiplying. So I don't have to use preservatives. I don't have to use certain things or all. So water activity gives you a fantastic idea. It gives you an idea what kind of microorganisms can grow in that product, which in turn will tell you what kind of preservation methods you need to adopt. Am I clear so far? Hello?
Yes, sir.
Yeah.
So,
All good. Please keep reassuring me now and then. Okay. Now you have, I'm sorry, this one is, okay. Now I have water activity and food. You see fresh milk and fresh meat, very high water activity, highly perishable. Fresh fruits and vegetables, high water activity, highly perishable. Cheeses. When you come to jam, it is 0.75 to zero point 0.8. So when you see 0.75 to zero point 0.8, only yeast and mold can grow. So whereas in case of a fresh milk and other things, I need to take care of bacteria, yeast, mold, everything. When I come to jam, which has got about 65% sugar, whose water activity is about 0.75, I don't have to much worry about bacteria. I need to worry about only about yeast and mold. Now, when I come to sugar, biscuits, and confectionery, look at the water activity. They are absolutely downright 0.2. 0.2 is bone dry. Nothing, no bacteria can grow. Now, this is the question I want to answer. Yesterday we were discussing. One gentleman asked me that why not we have wheat, grind it, it gets spoiled. Why not we dry it? Is someone asked, isn't it? Hello? 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 Hello?
Yes, sir. Yes, sir.
Yeah. So what happens, when you have a product of such low water activity, the moisture content is so low that further reduction in the moisture content will lower the water activity, but it's of no consequence, because 0.2, I'm sure the wheat flour, which is just ground wheat flour, will not have water activity more than 0.3 or 0.4 or 0.2. So further reduction in moisture content will reduce the water activity, but it's of no use because it's already is in the very safe zone. Now, in case of low water activity means low moisture, but they are not one-to-one relationship. Now, why do I say that packaging to maintain low water activity? Anybody?
So the contact between microbes and the product is limited in a package.
Uh, no, for example, I've got a wheat flour which already contains some microbes, right? And the water activity of the product is zero point 0.2. Will the microbes grow?
No, sir, because the water activity is
It
very
is
less.
low. Then why packaging becomes important in products with low water activity? Hello, girls. Hello, hello.
Sir, because maybe the if we are not packaging it, the humidity might increase the water activity in the air.
Yes. No, 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 no. The because of the outside humidity, the water will get onto the product, right? Right. When it gets onto the product, the moisture content would be high. The moisture content would increase, and its water activity, available water will increase, and the microbial growth will start. So that is why when you see very dry products, the packaging becomes very, very important because to prevent the moisture coming in contact with the food, by preventing the moisture coming in contact with the food, we are preserving the product, we are preventing the water activity from increasing. Okay, can I go to the next one?
Yes, sir.
It's not moving. I don't know what has happened.
You start again. You log in. I mean,
Uh,
log out and log in.
Let me see. I don't know why this happened. Can you see my screen now?
Yeah. Yes.
क्या हो जाता है यार?
टेक्नोलॉजी का कमाल.
It's a waste of time. Okay, now, so water activity becomes is a very, very important factor. So when you look at the product, you must have an idea about the water activity. That will give you a lot of information as to how to preserve the product, what kind of preservation methods is required. A product with a very low water activity, you don't have to heat it, you don't have to chill it, you don't have to kill the bacteria because the bacteria are in a very dormant stage, they cannot multiply. All you have to do is to pack them well so that they don't absorb moisture and increase the water activity. The second aspect or the intrinsic factor is and acidity. Microorganisms have a pH optima, maxima, and minima for their growth. Like bacteria is about 6 to 7, yeast 3.5 to 4.2. Mold guys are smarter guys. They have a broader range. So once you know the pH of your product, you can get a rough idea as to what kind of microorganisms it can grow. Microorganisms are small fellows, like my wife, and the, the 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 bacteria you have got a few which can stand up to even below 4 pH it can stand. which are called as the acidophilic bacteria. Okay, so now what the food technologies have done is they have seen that the microbial growth in a food product depends on the pH of the product, and based on the pH of the product, they have classified foods into uh, three categories: low acid food. Low acid means acidity is low, therefore the pH should be high, greater than 4.6. Then you have got medium acid foods, 4 to 6, and high acid foods, less than 4. Now, this 4.6 pH is a very crucial pH for bee food technologies because this is the pH above which the spores can germinate. And many of those Clostridium spores, which create a lot of problems because they are mostly anaerobes and they create problems in terms of production of acids and toxins and things like that, they grow above 4.6. So 4.6 is a cutoff pH. If anything is above 4.6, we always assume that the Clostridium will grow and we need to safeguard the food against it. So you have got low acid foods, medium acid foods, and high acid foods. So medium acid food, low, okay. And now look at the microorganisms under, especially I've picked up what do you say, pathogens which can create problem like Bacillus cereus, Clostridium, Salmonella, S. aureus, E. coli, Shigella, and all those things. All of them are the Clostridium is above 4.6. Most of them are about 4 and 4.2, 4.4. None of them are before 4. Sorry, below 4. So you can assume that all these gives you a good idea that if my product's pH is below 4, I am not much worried about these deadly microorganisms. If it is below 4.6, I am not worried about Clostridium. If it is below 4, I am not much worried about this pathogenic disease causing organisms. Okay, the Salmonella, Staph, these are the ones which we consume unsafe food. We have diarrhea, dysentery, E. coli, Shigella. We have all this diarrhea, dysentery, fever, and in the rare cases, death in case of Clostridium. All this because of these microorganisms. So you see the pH, it's a beautiful cutoff pH. So now you have got milk, meat, and egg products. They are low acid, and therefore you have two kinds of organisms. Certain organisms cause only spoilage, and certain organisms can be pathogen, can create problems also, and also cause spoilage. So when you have got products like meat, egg, milk, egg products, the products are low acid, right? That is, the pH is definitely above 4.6, between 6 to 7. Now, there is one more problem in this. Can anybody identify this based on what we have read till now? Hello? Hello? Hello?
Yes, sir.
Can you hear me?
Yes, sir.
Now, I was just asking a question. You have got the first one, milk, meat, egg products. It's low acid. Therefore, both spoilage and pathogens can grow. Now, it's a low acid. Low acid means the pH is low. Is there
Sir,
any
milk and meat but have a very high water activity.
exactly? So now you have read about water activity. Now you see that combined with the high water activity, it also has got low pH. Sorry, high pH, low acid. Therefore, they are all deadly guys. You have got to be extremely careful. That's why milk, meat, they are all highly perishable. Now, when you come to buttermilk, tomato products, vegetable products, they are all usually medium acid. It is mostly attacked by spoilage organisms and a very few pathogens. Maybe depending upon the pH, if it is close to 4, Salmonella will not come, coliform also may not come. If it is very close to 4, maybe S. aureus would come, depending upon it. But most of the cases, the medium acid product, that is pH from 4 to 4.6, only spoilage organism and a few pathogens take place. Now, when it comes to fruit juices and pickles, they are all high acid. Now, their high acid means their pH will be much lower than 4. In fact, if you take any juices or a fruit beverage or even a Coke or a Pepsi, the pH could be around 3.2, 3.5, which is a very low pH, and therefore there are only spoilage organisms. The product would get spoiled, but there will not be any pathogens, there will not be any problem if somebody consumes the food. Now, yesterday we were talking about Golgappapani. Now, why Golgappapani is safe? Despite the fact that the guy dips all his dirty fingers into it. Anybody?
So very high salt.
Very high salt. Okay, we were coming to that. Agreed. So, okay, that's one good point. It's a very high salt, therefore reduces the growth of microbes.
Sir, it's acidic in nature because of the tamarind juice.
Fantastic. Yes, it is acidic. I thought the girls would come up with the answer. Okay, so it is acidic in nature. Therefore, the pH. If you tomorrow next time if you have a pocket pH meter, you can check this Golgappapani. Right, it will be very acidic, maybe around 3.2. Therefore, no pathogens come in. No, no pathogen organisms come in. So we don't fall too much sick with those things. And why Golgappa is very safe? Hello? Hello?
Sir, can you repeat the question?
Why Golgappa is famous? I think you should be online. If you are not online, we can stop it. No problems.
Sir, actually my internet is not very stable. It was breaking up so.
But then there are so many other people are there, students are there. I don't see anybody talking. Okay? Why Golgappa is safe? Golgappapani, you said, okay, high salt, high acid. Then why Golgappa is safe? It's kept open.
So it's very dry. Basically, water activity is very low.
Exactly. Very good. Very good. So it's very low. The water activity is low. It's very dry. But what happens if I put that imli pani into that Golgappa? Won't the water activity go up?
Yes, sir, but the pH is also very high still.
And one more point. Any other point? This is how you must relate. This is how we must learn preservation, food technology. The point is that you consume it immediately. You don't keep it for hours together. Even for a bacteria, multiplication time is about 20-25 minutes. So you consume it very quickly. Yes. So Golgappa pani, the fruit juices, the pickles are all very safe because of high acid. Many of them have got high salt content. The next is oxidation reduction potential. Now, food is a mixture of oxidizing and reducing substances. So oxidation reduction potential, like a pH, you can measure it by equipment, which gives you the proportion of oxidizing and reducing substances. And that has got a direct bearing with the kind of microbes it can support. For example, if oxidation reduction potential is plus 500 to plus 300, it's only aerobes can grow. Plus 3 to minus 100, facultative anaerobes. That is, they grow best in absence of oxygen. Then, sorry, it should read minus 100. Minus 100 to 250, it's anaerobes. They cannot tolerate. So when you have a food, so along measuring your water activity, along measuring the pH of the food, you will also measure the oxidation reduction potential, which will give you an idea the kind of microorganisms which can grow in the product. Then comes the nutrient content. So microorganisms require certain basic nutrients for growth and maintenance. They are energy source, water source, nitrogen, vitamins, minerals, salt content, and so on and so forth. Okay, now if you take milk, milk is not only has got a high water activity, not only it has a high high pH, low acid, but it is also nutritionally complete. Good amount of protein, good amount of carbohydrates, fat, and everything. So the microorganisms will love it and then start growing on it. Whereas in case of a vegetable, the pH could be low, but then there is not much of a nitrogen source. So what happens on a in a pure vegetable? Not many bacteria which requires specific nitrogen sources may not be able to grow. That's why bacteria grows very conveniently over meat because it's a rich and a good source of proteins, whereas vegetables are not source of protein. So therefore, bacteria, all those kind of putrefacting bacteria, which hydrolyzes protein and things like that, may not grow on fruits and vegetables. Now, legumes are high in protein. That is your dal and other things is high in protein. Why bacteria don't grow there? Hello?
So the water activity is very low because they
Correct.
are dominant sheets.
Yes, they are very dry, they are very low water activity, therefore the bacteria cannot grow. Very good. So, so, so what kind of organisms can grow in a food? A lot depends upon the type of food and the nutrients present. For example, let's take the case of milk. The only sugar which is there in milk is lactose. So an organism which can consume lactose, hydrolyze lactose into glucose and galactose can only grow in the milk. Whereas other organisms which cannot consume lactose will not grow. For example, yeast may not grow in milk, will not grow in milk because yeast cannot consume lactose. Once, once the bacteria grows and hydrolyzes the lactose to glucose and fructose, sorry, glucose and galactose, then the yeast will come to consume the glucose. Whereas in case of a sugar product, the yeast is the predominant microorganism because that can very easily consume or utilize that carbohydrate. So it's very, very important that you to know the kind of nutrients which are present in the product and to have an idea what kind of microorganisms can grow. So, for example, I talked about sorry, salt content. If the salt content is very high, above 8% and 10%, nothing can grow except osmophilic, osmophilic or halophilic yeast, right? Very, but then the bacteria, most of the bacteria cannot grow. So if the salt content is, so salt is one way of, that's why salt is one way of preservation. Like we have discussed all these is, like for example, organisms containing proteolytic enzymes can utilize protein as a nitrogen source. So if the product contains only protein but then the organism must have a proteolytic enzyme to break down the protein into amino acids and to use it. But if the organisms cannot break down the protein, then it has to be supplied with basic amino acids. So that's what we have done. Gram-positive organisms are more fastidious in their requirements of nutrients as compared to gram-negative bacteria. That is, gram-negative bacteria can grow more widely and more frequently as compared to gram-positive, because gram-positive organisms are very particular about their nutritional requirements, whereas gram-negative are not. Then you have presence of the inhibitory substances. There could be a lot of substances inherently present in food which could inhibit the growth of microorganisms. Okay, then you have, for example, essential oils in spices like allicin in garlic, allyl isothiocyanate in mustard. Many of our spices, many of our spice oils which we normally use contains many substances which inhibit the growth of microorganisms. That is one of the our traditional preservation method has been going on by the use of spices which offer protection. Now, some bacteria, some yeast may produce natural microbial preservatives like niacin that also offers protection. But these inhibitory substances play a very limited role. Only on them you cannot preserve it. They can support they can aid, they can be a part of the whole program, but only on these you may not be able to preserve a food. So you require other methods also to preserve. Now I have a quiz so that I can take a break. Why pickles have a longer shelf life?
Sir, because they have high salt content.
Good.
They are packed airtight in a container.
Now what if I
Uh,
open it? What if I open it and I don't, I open it, use it again, I open it and use it again.
Sir, it also has an oil layer on it, which reduces the air interaction.
Very good. Anybody think else? Anything else?
Sir, we use mango and amla and stuff, so the pH is also acidic.
Very good. So what are the pH is likely to be?
Sir, below 4.
Very good. It is likely to be below 4. Therefore, most of the pathogens will not grow. Only the spoilage organisms would grow. Anything else? From the point of view, from what we have just seen now. अरे यार पिकल में एक बहुत इंपॉर्टेंट चीज हम डालते हैं आप लोग यस हेलो
Sir, is it salt?
सॉल्ट तो बता दिया ना पहले ही
Andhra people enjoyed more when it is there.
हाँ करेक्ट
Spices? I mean,
Yes, spices.
chili.
Yeah, spices, chili, garlic. We add so many things because, like I said, just in the previous slide, we saw that many of the spices has got many, essential oils and other bioactive substances, which do offer protection against uh, uh,
Certain
microbial.
kind of microbes.
Cannot be the only thing, but yes, it does offer protection. Anything else? Any idea about the water activity of pickle? पिकल कैसे बनाते हैं साहब गर्ल्स आर रन अवे
Sir, I know about the South Indian pickle, but not the North Indian one.
Yeah, I'm a South Indian. Yeah, tell me how Indian South Indian pickles are made.
So, sir, there is this thing called ava,
Hmm.
which we use the powder of,
Hmm.
and we add some chili, salt, a lot of salt, a lot of chili, and ava together, and we use mango. We use freshly cut mangoes,
Hmm.
then marinate it in
Correct.
an oil-filled container with these spices.
Correct. Do we add water?
No, sir.
We don't add water. So what do you expect the water activity to be? Low.
Very low.
Yeah, because of the salt content, because of the osmotic dehydration, which we will see little
But
later.
sir, what about the water released by the mango itself?
Yeah, water. Good question. The point is that is taken care of by your high salt. But there are many pickles. The water which is released by the mango, you have a lot of salt in that. Therefore, the salt content would go above 8% and act like a preservative. So that's one of the reasons you will not have much free unbound water in pickles. They may be all bound. Therefore, the growth is also retarded. I have not measured water activity of pickles, but then it's expected to be low. I don't know if you, I don't know, my mother never used to allow us to put a wet spoon into a pickle.
Yes, sir.
Why?
It will increase the water content, which will make the microbes grow.
Yeah, it'll increase the free water.
Yes, sir.
Possibly. So generally, they never allow us to put wet spoon into the pickles or wet spoon into even sugar because sugar is a very dry product. Minute you put a wet spoon, the moisture content will go up, the water activity will go up, and the microbes will start growing. Yes. So pickles. These are called as the hurdles. So you create hurdles to the microbes for their growth, in their growth. So one hurdle is your salt content, other hurdle is your oil content, others is spices, others is low water activity or low water content, right? And then the pH is low because so it offers so many hurdles for the microbes. So what happened? The microbes gets tired in overcoming these all these hurdles, and finally it gives up, and then the product is made safe. So this is also sometimes we call it as a hurdle technology. Okay, so simple thing like if my pH of my pickle is 4.2, I will try to reduce it to bring it below 4 so that I increase the safety. I create a huge hurdle for the microorganism. So why curd has a higher shelf life than milk?
So the protein is already digested in curd.
No, sir. So if protein is digested, the microbes will enjoy it.
Sir, it has a very low pH.
Why? What happens during fermentation of the milk? It's your field, yeah.
Sir, formation of lactic acid.
Yes, formation of lactic acid. The pH somewhere from 6.8 to 7 drops drastically to about 4.2, 4.3, and there is also a slight. It is very close to the isoelectric pH. Therefore, there is a coagulation. There is a precipitation. Not precipitation is more of a coagulation curdling, and therefore, and then since the pH is uh, uh, much below 4.6, therefore it doesn't offer bacteria. It offers greater resistance to bacterial growth. Yes. From the water activity point of view, can you say curd is better than milk? I don't know. I don't know.
So the water activity in curd will be lower than milk because it is solidified, semi-solid basically.
No, I have no idea. I think I'll have to search it out. What is the water activity of curd? Okay, let's get on.
Sir, can we say that the water activity on the surface would be high, but inside it would be very low?
No. I don't think you can say that. No, it could be uniform.
Okay.
I need to see that. I think I have asked a question. I will also check whether what is the water activity of a curd. I think it should be almost same as that of milk, unless the protein binds to water while coagulation, and then I don't know. I need to check.
No, I think the water is excluded, excluded because of the precipitations.
So the water
Curd-
activity should go up.
Yes. Overall, the water level goes up.
That's correct. Let's check. Let's check the one. Okay, let's get on to the extrinsic factors. That is factors which are related to the outside environment and not related to properties and not related to the properties of it. The first, of course, is temperature. Every organism has an optimum, minimum. You guys know this better. Below minimum, you have a static effect. It doesn't get inactivated, but it is retarded. Above the maximum, the inactivation takes place, and um, there is a reduction of microbes. Now, classification of microbes by temperature, you know that psychrophiles is something which can grow at low temperatures. Psychotrophs, psychrophiles are the one which love the low temperature. Psychotrophs are one which can tolerate low temperature. Mesophiles room temperature, and thermophiles you have got higher temperature. So, so obviously thermophile, if a product has got thermophile, you need to have a higher temperature to inactivate them, but they may not grow at low temperature. So when you're refrigerating the products, then you have to be bothered about psychrophiles and psychotrophs, not thermophiles and mesophiles. Oxygen requirement, we know from the standpoint of the ability to utilize oxygen. Free oxygen classified into aerobes, which require oxygen, a must. Anaerobes grows only in absence of oxygen. And then facultative anaerobes grows best in absence of oxygen, or microaerophils. There are many classifications of that. Okay, so for example, suppose I have a product, if I do a vacuum packing, right? I have a product, I do a vacuum packing. Vacuum means I completely remove all the air from inside. Now, am I making the product safe? Hello?
Yes, sir,
Yes,
because
sir.
Yes, sir?
you are basically removing the contact between microbes and the product.
Microbes in the product? No. I am completely removing air from my pocket, I mean, from my package,
Sir, we are reducing the amount of oxygen,
So,
which will reduce aerobes interaction with the material inside.
are we bothered only about aerobes?
No, sir.
We also need to take into account,
Anaerobes and
yes, anaerobes. Okay, so and facultative anaerobes. So that's exactly the point. The point is that not that every time when you do a vacuum packaging, you are completely making the organisms not grow, because then you need to be bothered about anaerobes. If the product can support anaerobic growth, then vacuum packaging may not be the answer, because it'll activate those anaerobes for them to grow better. And mind you, the anaerobes, they create more problems. They are Clostridium. Most of the class Clostridium species are anaerobes. They in absence of oxygen. In fact, presence of oxygen, you don't get much foul smell. But when the anaerobes grow, mostly they are putrefying. They grow on the protein, produces amino acids and H2S, and all the reductase reactions takes place. Foul smell, and most of them produce toxins. In fact, anaerobes are more dangerous as compared to aerobes. Okay, so once you know the type of product, once you know what kind of organisms which can grow, and that kind of, then you can also study whether it's an anaerobe or an aerobe and things like that, and decide your plan of action. Other extensive factors are like processing. Now, if my processing has a heating step, then I can say that this will reduce the microbes. So, to some extent, that processing step would help. Then you have got addition of preservative. This is one important, of course, we food technologists heavily depend on it, and many of them don't like, many of the people don't like it. Is that addition of preservative that we have already discussed? This could be one more hurdle for the microbes. For example, classic example of pickles. Now, pickles has to be preserved. In fact, uh, 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 pickles are kept for, if not for years, definitely for months. For the whole year, not my wife, my sister has already made mango pickle for the whole year, because mango is available only in these 2 months, so she makes it. So the point is that they have to be preserved for a longer time, point number one, and they cannot be heated. Obviously, if you heat a pickle, the whole taste and everything will change. So it's a non-thermal process. There is no heating involved. So you need to create as many hurdles are possible. That we have seen all the hurdles like pH, acidity, and salt content and things like that. Preservative is also one of the hurdles which is quite commonly used, not at home, But if you see any normal pickle which is available in the market, which has got a shelf life of about 9 months and 12 months and things like that, invariably contain preservatives. And those preservatives are absolutely safe, standard, and perfectly allowed by the food authority. So addition of preservatives is one of the extensive factors which can, which has a lot of role to play in the microbial preservation. Then relative humidity, we have already seen it. Relative humidity is that roughly an amount of moisture which is there in the air. Higher the moisture content in the air, then obviously it will slowly transfer to the food, and thereby the food's moisture content will go up, its water activity will go up, and therefore your product may be perfectly all right at this point in time. It may have a very low water activity, but minute you allow moisture to transgress, it'll increase the moisture content, water activity, and hence the microbial growth. Simple thing, you fry papad and keep it for some time, especially in places like Chennai where the humidity is very high. It loses its shape because it absorbs moisture. Now, papad has got a water activity of 0.2 and lower than that. But minute you keep it exposed, the water activity goes above 0.6, 0.7. Allow enough time, then you will start microbial growth will take place on the surface. So relative humidity is very, very important. It's an important extrinsic factor which is taken care of mostly by packaging. So that comes to packaging. We will do a little more in our technology of preservation. We will do a packaging little more in detail. So packaging is a very important extensive factor which plays a very important role. In fact, one of the essential feature or the function of the package is to protect the food from the external environment. Then storage conditions, including modified atmosphere. We will see little later as to how to modify the atmosphere, especially in case of fresh fruits and vegetables, affect the growth and the spoilage and things like that. So storage conditions are very important. I'm sure you would have bought some frozen fruits, frozen products like chicken or frozen nuggets and whatever it may be, and one of the conditions on the packet would be keep it frozen. So the frozen products are they are told to be kept frozen. So you have to maintain at the frozen conditions. If you don't store them at the frozen conditions, then the bacteria and all will start multiplying, because freezing has only stopped the growth of the microorganism. It has not inactivated it, which we will see in the other. Then end use of product. So many times end use of product, we give instructions to the product as to how to be consumed. For example, let's take I don't know how many of you must have bought a Tetra Pak, aseptically packed Tetra Pak juice, 1 liter juice, Dabur or something. And then in that 1 liter pack, they would have written, keep it chilled, or after opening it, keep it in the refrigerator. And then consume within 5 days and things like that. So these are as long as the package is not open, there is no interaction with the external atmosphere, the product is perfectly fine. But the minute it's opened, then it starts interacting with the external atmosphere. The external atmosphere could have yeast, it could have molds, bacteria, which can come into the product. So the manufacturers suggest that you keep it refrigerated and use it within 5 days. So these are also important factors from the point of view of preservation, because that is how the safety of the product or the product is preserved, especially in these kind of cases. Okay, now the bulk of our talk has been on microbial, obviously, because they are the major cause of issues, and of course they are not the alone one. They are their cousins are chemical and enzymatic spoilage. Now, enzymatic spoilage usually happens when softening of fruits and vegetables, especially the fruits have got pectinases, and the pectinases are present in different cells. Minute there is a bruise or a damage to the fruit, the pectinases are released from the cells, and then and the outer layer of the firmness to fruit is given by the pectin, and that is acted upon by these enzymes, and then those it will start losing its shape, and it will start liquefying and things like that. So these are some of the spoilages which take place due to enzymatic. And then like we discussed, enzymatic browning also, polyphenol oxidase, especially in case of uh, brinjols and things like that. There are enzymes which can convert the polyphenols into their polymers, which in presence of oxygen starts browning. Then you have got chemical spoilage in food. The classic example is your oxidation rancidity. Like you have a, suppose you keep a, I don't know how many of you have experienced any fried item kept for a very long time can have a rancid note. This is especially in case of almonds, even peanuts, which have got a high fat content. If they have not been properly taken care of, these almonds and these peanuts have got oil, which is made up of fatty acids, which are many of them are unsaturated. Unsaturated means you have got double bonds, and these double bonds are very reactive species. They react with oxygen, and they produce lot of decomposition or decomposed products, and some of those products like peroxides and hyperperoxides, and uh, uh, they create that rancid odor. In fact, if you see that almonds and all, if you eat it, you will find at the end a very rancid note, and that is a chemical spoilage, and that can be prevented by the use of antioxidants. Now, light also is can also cause damages. It can cause decoloration. It can cause and light, heat, both are catalysts for rancidity problem in oils. Uh, I don't know if you can. I don't know. This is an oil pack which is not very clear. Uh, if you take any oil pack, vegetable oil which you buy from the market, just see the ingredient listing. You will find some substances called antioxidants are added, and these antioxidants prevent the oxidation of the fatty acids, which produces rancidity. And by preventing this rancidity, you are also by preventing the oxidation of the fatty acids, you are also maintaining the nutritional value of the oils. Many of the oils are valuable for their unsaturated omega-3, omega-6 fatty acids, and if they are rancid, if they are oxidized, then they are no longer available for the human body, which is so. So you have a microbial spoilage, uh, uh, you have a chemical spoilage. In chemical spoilage, you could have enzymic and chemicals spoilage. See, microbial and chemical spoilage depends on the combination of both intrinsic and extrinsic factors. So these factors are to be leveraged while determining the preservation method. So what essentially happens is that you need to thoroughly understand your product in terms of water activity, in terms of pH, in terms of over oxidation reduction potential, the nutrients present, what can grow. So you will have a fair idea what kind of microbial growth which can take place, and also what kind of chemical change which can take place. Suppose if my product does not contain oil, maybe I will not be much bothered about rancidity because I don't have oils. But if my product has got too much of oil, then rancidity becomes a big issue. If my product has got a high water activity, maybe my microbial growth is important. So all these factors have to be taken into account by studying the food, by studying its intrinsic properties, And also you should know what are the likely extrinsic properties which can spoil. Based on all these things, you we need to decide what kind of preservation methods to be used. Okay. Uh, the preservation methods can be either heat, low temperature, drying, chemical preservatives. Now, heat treatment will lead to what? Inactivation, inhibition, or avoiding recontamination.
Sir, inactivation.
Very good. Low temperature.
Inhibition, sir.
Inhibition. Very good. Why only one person is saying drying?
Same inhibition, sir.
Why?
Sir, it would depend on what kind of drying. If it's dried by heat treatment, it would be inactivation and inhibition.
Very good. I think it's a very sensible answer. Yes, drying, what kind of drying you are using and what temperatures are employed, agreed, agreed. But most of the cases, dryings are at low temperature because if I dry it at a too long at a high temperature, the product would be spoiled. We will study a little bit detail in the next lecture. But most of the cases, the drying reduces the water activity. Many cases, it's inhibition, but there could be inactivation also. You're right. Yes, sir. Chemical preservatives. Hello. Hello.
Yes, sir.
Hello. Yes. Chemical preservatives. What kind of
Sir, inhibition.
inhibition? Correct.
And in some cases, recontamination as well.
No, no. Recontamination could be common for all. So that would take care of by the packaging. So recontamination would uh, okay. In case of yes, I think yes, you are right. That's a good point. Yes, in case of preservatives, we can also talk about because even if the bacteria come from outside, you are preventing it by the use of preservative. Right? Agreed. Correct. Right. Packing,
Recontamination, sir. Stopping it.
recontamination. Now there are interesting points. There are some inhibition also in inactivation also is there in case of packaging. Uh, that is what is this intelligent packing and active packaging, which we will study. So some of them could involve inhibition. Okay, fermentation.
Sir, we increase microbial activity in it.
See, you could the fermentation could uh, inactivate or inhibit the other growth of other organisms. For example, you have curd to milk to curd, and because the pH is low, not many organisms can grow on. Traditional method we will see, modern method, high pressure processing we will see. Okay, so this completes the principles of food preservation. Very, very broad view. Any questions on this?
No, sir. Okay, sir, I just have one question.
Yeah.
So, can we say that when we actually when we put dry fruits in water, we reduce its uh, nutrients?
Dry fruits means what?
Almonds, sir.
Putting in water.
Yes, sir.
See, what is
By
your
like my family says ki put the almonds in water, then eat the almonds and drink the water. Does it do any good?
uh, uh, I off the hand, off the cuff, my answer would be no. Because if you put the almond in water, nothing much will come out of it. So I don't know what is the idea of putting it in water. One way, whether to soften it, it could be softening it. Yes, that could be one way. For elderly people, one way could be to wash it out if there are any other substances, but then you are drinking the water also. No, I can't think of. I can't think of.